Welcome back to Further Solutions Academy. Further Solutions Academy. On this video, I'll be walking you through problems on metric space. Don't forget to share the video, subscribe if you have not subscribed before, and we have a lot of videos for you to watch. You can also reach us by commenting below. And any of our video, make sure you comment on it for moderation purpose. If you want to book for our online class, you can comment below, or you make use of this line. With this line, you can call us, you can WhatsApp us, and Telegram is allowed also. Either of the three, you are good to go. That is all about that. On this video, I'll be working on problems on metric space. This is the problem, this is the question I want us to solve together. It's a very nice question that I picked somewhere in the textbook, and let's see how it goes. Now I have let S and D be on a metric space, metric space for X and Y are in X. Define this to this. Show that D is also a metric space on X. To explain why no 2 points in X are distant of on or more apart on that matrix D. Now let's see. I will need to rub this point because of I have to show some things. The first one is to show that this particular function, this particular metric space is a what? Is a metric space. Don't forget what I told you in the first video. It means first, second must satisfy. First, second must satisfy. Let me try to make some things here. Let's try to talk number 1A, which is A. Now, I'm to show that D is also a metric space. Now, what I need to do, number 1, don't forget the property of a metric space. The first one, since D of X will always be what? Greater than equals to what is 0. I've told you that it can only be equals to 0 if and only if the X and Y are of the same point. Don't forget the same location. Now, it means what I'm trying to do here is that don't forget this is what I'll be working on at this point. Now, it means my D of X divided by what? 1 plus D of X will also be what? Greater than what is 0. That is to say, my big D of X, Y is also greater than what is 0. Greater than equals to what is 0. Okay, that is very, very correct. It means what am I trying to do is that, let me quickly try to explain this. If I'm just trying to show some, if D of XY equals to 3, for instance, it means I'm talking about 3 divided by 1 plus 3 will be greater than what is 0, which I have 3 all over 4 is always greater than equals to what is 0. That's what I'm trying to say there. That is the normal illustration there. Okay, because of that. Another one is that it means that is very correct. Now, the second thing I want you to know here is that the second condition, which is condition 1, condition 2, is that I have D of X of Y will be equals to D of, that is what I mean. I've explained this that time that when you have a distance like this, X and Y, now going is also the same thing as coming. That is what I explained the other time. It means what I'm trying to do is that my D of XY, which is divided by 1 plus D of XY, will be equals to my D of X, my D of YX divided by 1 plus D of YX. That is what I am trying to explain to you. It means my D of XY, it will be equals to D of YX. That is what I am trying to explained to you there. Now, I think I've shown first and the second property of metric space. Let me move on to the next one, which is, I want to move on to the third one. I need to rub this junction. Now, the third one is summer. I need to show something there. Please take note of D. Okay, number third one. I want to show for the third one. The third one let us to know that, I don't know, how do I do this one? Okay, what I want you to know is that this is where the real work is. This is where the real work is. Permit me to rub the whole question, and because I have to do some little manipulation, computing rather. I have to do some computing there. Please take note of the question. That is where the third property let us to know. What I want you to know is that we are talking about that is to the d of xy plus d of yz will be greater than equals to d of xz. That is what the third property is saying. Now, if I should do something now, I can say that my d of xz will be less than equals to d of yz plus xy plus d of yz. Now, it means I just change position. When I have s is greater than y will be less than what? X. That is what I'm just trying to do there. Since I have that now, what I'm trying to do is that, okay, how do I show this thing that it will be very fine? Now, let me try to now let me show some generate a function of f of x, which is equals to x all over 1 plus x. Okay, that is what I'm trying to say. It means I'm saying by d of x of y will be equals to d of xy divided by 1 plus d of xy. That is what I'm trying to say that. Okay, now every increase on the positive real number, it means every increase, we call it monotonic increase. Okay, I've done something on monotonic increase on our work, on our video. You can check on the real analysis. Every monotonic, which is positive, is also means positive. Sorry, for those that are still learner, positive increase. At this point, I'm not expecting learner to be here because this is advanced mathematics, which is known as positive increase. Okay, it's also now it means my d of xz will be less than equals to d of xy plus d of yz. Okay, now what I mean there is that my d of xy equals to d over xy divided by 1 plus d of xz, which is less than equals to, if I should do something like this, I can see that it's less than what is here. I have d of xy plus d of yz divided by 1 plus d of xy plus d of yz. That is what I'm trying to do. With this, it also equals to what I'm having here. I can do like when I have a plus b divided by c, I can as well write it as a all over c plus b all over c. That is what I'm trying to do there. It means I can turn this by having d of xy divided by 1 plus d of xy plus d of 1 plus d of y z divided by 1 plus d of xy plus d. That is what I'm trying to do there. Since I have that, okay, from here now, from here, I can continue by having, okay, with what is on ground now, I can say that it will be less than equals to d of xy divided by 1 plus d of xy plus d of z divided by what? 1 plus d of y z. Okay. Now the next thing I need to understand is that my d of this, it will be d of xy plus d of y z with what is on ground now. Hence we have to show that d of x comma y, d of y x comma z, it to be less than equals to d of xy plus d of sz. This is sy. YZ. Okay, that is what I mean by that. Okay, since I have this, I think I've done something very good for you. Okay, with just on ground now, I can now redirect it by having, which implies I can redirect this thing by having d of xy plus d of yz, it will be greater than equals to d of, okay, with this I think I'm good to go. Since I have this, it means permit me to use this part of the board. Now it means what I'm trying to do is that I have the of xy equals to d of xy divided by 1 plus d of xy. Now let's assume I have some d of s. Let me say d of s is equals to d of x is equals to 5. It means I'll be having 5 divided by 1 plus 5, which is equals to 5 divided by what? 6. Now, since I have 5 divided by 6, there is always what? Increase here. There is, this place is always greater than what? This place is higher, is larger than down. I mean up is larger. It means here is larger than up. Since it's larger, it means the condition will now state that what? It means by having that kind of things, it means since d of x of y is the same as the both the denominator and the numerator will also have the numerator being larger than the numerator, so that 2 points in S will be what? Distance on or more apart in D. I think I've showed that, and that is all what I need to do. Once again, thank you for watching. Further solutions.